and the fan is connected to the frequency converter to control the speed of the fan. So the frequency converter is connected to the PLC. Okay, here we have the circulation pump. So the circulation pump is a display and adjustment wheel here. So if it shows this symbol, it means the pump is on, as well. If you get this symbol, the pump is off. This can be adjusted manually on the pump, or for sure we can adjust it with the relay or connector to start the pump and stop the pump. The settings adjustment of this pump must be set to the right settings. We have one setting must be done that the pump mode is on manual mode speed. That means we have a fixed ramp for a speed and it's not pressure controlled or something like that. And the speed must be adjusted on 2700 RPM in the pump. So usual, if you get the stuff from Schnell, the settings should be adjusted, but if we replace the pump or something, we always have to cross-check that the settings are right. We have the AME445. That's the valve actuator system, what we have on the charge air cooler safety module, and as well on the HTU, so heat transfer unit. We come to that later on. So the function of the valve is, this is the lifter. If the lifter is pushed out, means the cooling cycle is open. If this pin is long, if the lifter pulled in, it means it's short. The pulled in means the cooling cycle is closed. So only for understanding, over that pin with the motor, so the actuator on top, we actually control this pin, the position of this pin, and this pin actually control the position, how much flow goes directly from here to here or from here to here. We have here a symbol or a letter that's A, that's B, and it's AB. So we're running from A to AB or from B to AB. So, and this will be controlled with the three-way valve and the position of this pin here. On the valve by themselves, we have this actuator. So the actuator have different options to adjust. Always important, if you get a new actuator motor and you have to replace it, please ensure that the adjustment is exactly on the requirement. Okay, the housing direction is like that, it shows the arrow, but on the motor, please check the instruction. I will send it to you as well. But on the other hand, if you don't have the instruction, always check the wire diagram of the Schnell CHP. It could be in different versions of Schnell that they have different settings of this motor. If the setting is wrong, either the control is not working properly or the response signal is not working properly. So always make sure. That's a short. There's a screenshot from a wire diagram of one of the Schnell CHP, and there we can see as well how the dip switch, that part must be switched, and here is a bridge connector what adjusts if this motor is operating on voltage, so U, or it's operating on current signal, so E, so I, and this switch actually adjusts what kind of signal is used and how the motor operates. So always ensure that this settings and this bridge is working right or is connected right. So we have here the cockball dirt trap filter. This is a dirt trap filter what is directly in the safety module here. So safety module here. That filter inlet is sitting in here. If the valve is open, so the filter will sit like in that, and the water can run through that filter. If there is any dirt, it will get stuck in that filter. So the filter by himself is tied with a spring ring. It's around here. Important, if you like to clean that filter to clean, you have to close the ball valve. And what that means on the opposite side, if you close the ball valve, you will close the circulation of the charge air cooler water system. So if you close the valve to clean the filter, you have to make sure that you only do it if the CHP is stopped and not operating. So if you close the ball valve, there will be no cooling on the charger anymore, and the charger will rise and can produce damages on the CHP. So please ensure that you only clean that filter if the engine is stopped. Okay, so we have here the charger safety module. We have here the expansion tank underneath. The expansion tank needs on the gas side a pressure of 1.5 bar. It's different to the HTU. So different cycles will have different pre-pressure on the gas side of the expansion tank. Please keep that in mind. It's not all expansion tanks have the same pressure. It depends on the system and the volume, not, but on the operation temperature of the system. If you operate with a higher temperature, you have a lower pressure, usually on the gas side. If you operate with a lower temperature, you will have a higher pressure on the gas side of the expansion tank. Okay, and the water system, the cycle system, must be filled with a water pressure of 2 bar. If the cycle or the water is cold. If the water is warm or hot or warm, then the pressure should be around 2.5 bar, and we can again see it here on the pressure gauge. Yeah, here is the pressure gauge. Okay, heat transfer unit H2U 300. So the 300 is the heat transfer unit designed for the 6R21. So it's actually designed for maximum heat transfer of 300 kilowatt. So for the bigger engines or CHP of Schnell, they will use a bigger size of a HTU, and for the smaller one, a smaller size. So we have here the cooling water flow of the HTU. That's the HTU actually. So we have flange connectors on the HTU. One thing is the supply to the client or to the plant at the plate heat exchanger. We have connector for the external emergency cooler cycle. We have connectors for the engine, where the engine cycle is connected. And we have connectors at the exhaust gas heat exchanger, where the external exhaust gas heat exchanger is connected. Okay, so the design of the HTU is actually made that everything, all components of the heat recovering or heat transfer unit is on one frame in one kind of unit. That's the idea of the design, that not all parts are different somewhere on the walls or separate. So on the whole system here on the HTU, we have the primary pump, we have the motor pump, we have the plate heat exchanger installed, we have the hydraulic separator here, up, right, down, and we have all the safety temperature limiter. So this is that one up here. So the LTS safety temperature limiter is a temperature switch. And then as well we have the under pressure switch, what's mounted under here. and we have a flow. We will go in detail. We have the flow meter here. We have pressure sensors here. All together, we have temperature sensors of all the different points here, and we have the cabinet where the controller is sitting, all on one frame. So we have a over pressure switch. So that's the pressure release valve on top of the hydraulic separator or deflector, depends on the naming. So, and from here you have, again, if the pressure exceeds here, the valve will open and release water and pressure through that pipe. So if this pipe is always leaking, then either we exceed the pressure in the system. So this could be a point that the expansion tank is broken or not working properly. So the pressure exceeds the maximum pressure of the pressure valve. Or if it's leaking, that there's a red cap on it, and you can turn it. And if you turn the cap, it starts slowly to open the valve. And then if you turn it wider, it gets over a point, and the valve will close immediately again. So it's like a spring valve where you can turn. So if there is dirt in between the valve and the closing point, so if there is dirt or whatever in between, then it could start to leak through that valve as well. So then we have to either flash it quickly that we get the dirt out between the seals, or the valve by itself has some problems of leaking. So we have two dirt traps filters on the HTU. We have one, there's the mainline filter, and we have a bypass filter, is the second one here. This is the two blue items here. So with the automatic switch, that means the control will automatically switch to the second one, so the bypass one, if the first one gets some problems. We have temperature sensors and we have pressure sensors, what I mentioned already. We go into the sensor in a separate video, much deeper about all sensors or function of the CHP. Yeah, so we have here's the emergency cooler connector forward flow, and there is a shut-off valve. So always important, make sure that all shut-off valves are open before you operate the CHP. Number two, we have here the terminal box with the PLC modules, breakers, and so on, directly mounted to the H2U unit as well. Hydraulic separator, hydraulic deflector is that square or big square pipe where the different cycles are connected. Let me know if you like to get a video or more know about understanding of a hydraulic separator. It's very important to understand why and how the separator must be in place and how it works. Okay, number four. So it's here on top, it's automatic air release valve or relief valve. So there is a floater inside, so if there is air bubbles, the air can go through. If the water reach the point, it will close the valve again. So it's automatic release. So and then we have number five. You see on the bottom, we spoke already of it. It's a minimum pressure limiter. So the minimum, so it's on low pressure. Temperature are always on over temperature, and the pressure here is on under pressure or low pressure. Then we have here the cap valve for the primary expansion tank. So the expansion tank will be later on connected directly here at number 6. Number 7, here the primary pump. The primary pump is the pump for the primary circle to supply the heat to the plate heat exchanger and the client or plant. Number 8 is actually the engine pump, so the cooling water pump. That's here. Then we have number 9. It's the other side, the return flow connector flange with the valve, with a shut-off valve for the emergency cooler. So the forward flow here, number 1, number 9, the return flow from the emergency cooler. radiator. Then from the other side, we have here number 1, the three-way valve for the emergency cooler. Number 2, we have the bypass valve of the blade heat exchanger. Number 3, where's number 3? Here on top, where, yeah, the safety valve again. This is the overpressure safety valve. Again, this with the red cap. And this release pressure. If you get overpressure over the limit, there's a spring valve over the limit of the valve that will release through that pipe and release it here to the floor. Number 4, that's the dirt trap bypass line with a shut-off valve motor. And number 5 is the main line dirt trap with here the main line, here the bypass line. Number 6 frame is clear. So this is the shut-off valve here, number 7, in front of the bypass dirt trap. Number 8 is this big unit here, is the blade heat exchanger to transfer heat. So first to separate the cycle of the H to U and separate the cycle to the client. To transfer heat from the primary cycle of the CHP to the client side. Oh, I forgot number 9. Number 9 is here the over temperature switch, so the or limitator. It's here on top. It's a gray box, and here on top to measure the temperature. And this is a switch that means if we exceed the temperature, it will switch off the CHP with an error message. Okay, so filling pressure, heat transfer unit. So the filling pressure in cold is 1.0 bar. The warm filling pressure is 1.7. So if we operate in cold, that means the pumps are operating. The pressure should be on 1.7 bar. If the